Alright, let's break down the working of a permanent magnet synchronous motor, or PMSM. If you're into electric vehicles or just love geeking out over efficient motor tech, this is one you'll want to pay attention to. So, what even is a PMSM? In simple terms, it's an AC motor whose rotor uses permanent magnets, not electromagnets, to create a strong magnetic field. That's a big deal for efficiency and performance. Reasons why you'll find these motors powering everything from EVs to industrial robots. Let's dive into the key components. First, there's the stator. Imagine this as the outer shell with three-phase windings. It gets its juice via an AC power supply, usually from an inverter that converts the DC from your EV's battery. Then we've got the rotor. Instead of copper windings, this guy is loaded with powerful rare earth magnets. Think neodymium. Last up is the inverter or controller. That's the brains of the operation, converting your battery's DC into smooth, three-phase AC for the stator. Now here's where the magic happens. When you send a three-phase AC current through the stator windings, you get what's called a rotating magnetic field. The permanent magnets in the rotor? They're just itching to follow that field. So the rotor aligns itself and spins in perfect sync with the stator's magnetic field. Zero slip. That's why it's called a synchronous motor. Torque generation is where things get really interesting. As the rotor's constant magnetic field interacts with the stator's rotating field, torque is produced. Essentially, that's your motor doing useful work, like moving an EV down the road. The torque depends on the angle between the fields. Think of it as a kind of magnetic dance. And to keep everything perfectly coordinated, advanced control techniques like field-oriented control come into play. These use sensors to track the rotor's exact position, so the controller can adjust the current and keep the rotor locked in sync with the stator field. It's how you get that buttery smooth acceleration in modern EVs. Now, why do engineers love PMSMs in electric vehicles? For starters, they're super efficient, over 90% in fact. They punch above their weight, literally, with a high torque-to-weight ratio. They also shine at low speeds, making them perfect for start-stop city traffic. Plus, they're compact, lightweight, and offer precise control. All wins for EVs. But it's not all sunshine and rainbows. Those rare earth magnets? Pricey. They can lose magnetism if things get too hot, and the control systems, while awesome, are pretty complex. If you want a quick mental map of how all this fits together, picture this. The battery feeds DC to the inverter. The inverter converts it to three-phase AC for the stator. The stator creates a rotating magnetic field. The rotor's magnets follow, and you get mechanical output to the wheels. Simple as that. Curious about how PMSMs compare with other motors, or want to see a diagram or simulation? Drop a comment and I'll make it happen. Thanks for watching.